Good evening, students and parents. Hope you're doing well. We're going to continue looking at mixed numbers, except instead of adding mixed numbers, we're going to be subtracting mixed numbers. So that means we're going to have a larger number and we're going to subtract a smaller number from it. And when using mixed numbers, sometimes that means changing the proper fraction into an improper fraction. Okay, it's week 31. We've done addition of mixed numbers. Now we're going to look into subtraction. And just like when we subtract whole numbers, sometimes subtraction is a little bit more complicated than doing addition. Addition is pretty straightforward. In subtraction, we do a lot of borrowing or regrouping. We're going to have to do the same thing for these mixed numbers. And the thing we're going to have to regroup is this side over here. So we're going to focus our attention on this fraction here. And the reason being is if we took these whole numbers away, if we start out with 3/11ths and we want to subtract 5/11ths, it's not possible because we only have 3/11ths over here. If you had a pizza that was cut into 3 pieces and 5 people came over and 3 people took them away, there'd be 2 people that didn't have any. All right. So we can't subtract 5 from 3. It's just this fraction's too small. So we're going to have to regroup using this one. And we're going to be regrouping using the whole fractions again. And we're going to start creating improper fractions to subtract. So there's 2 ways of doing this. I'm going to show you the first way. Let's take a mixed number, 7 and 2, 6. And let's subtract 5. Now our whole numbers we could subtract. And 5, 6. I'm going to make this fraction larger than that fraction. Now you're going to say, okay, Mr. Buddingham, why'd you do that? Well, these things kind of happen sometimes. Sometimes you can subtract the whole numbers, but you can't subtract the fractions. So we're going to take this one step at a time, and we're going to look at the fractions first. Okay. Then we're going to look at the whole numbers. So in addition, we added the whole numbers first, then we add the fractions. In this case, we're going to subtract the fractions and then subtract the whole numbers. So again, I'm just looking at this one over here. And I'm going to say, okay, well, I'm going to have to increase this fraction somehow. So I'm going to take this 7 and I'm going to make it a 6. I'm going to drop it down 1, well, I could say 1 unit or by 1. I'm going to change that 1 that I took away and I'm going to add it back to it as a fraction, a whole fraction. And then I have this 2, 6 as well. Now this is a very interesting thing we do in math. We do this a lot in math. This part over here still is the same amount as that part. I didn't increase the value over here. I kept the value the same. I just rearranged the values in a way that's going to help me solve this problem. Now I'm subtracting, and we're going to keep this one the same. 5 and 5, 6. Okay, so that one stays the same. Again, we're only focused on this side right now. Equals. So I wrote my equation down here. This is equal to this part. I'm going to do some work over here. I'm going to take this part over here that I'm focused on, and my whole number stays the same, but now I'm going to add my whole fraction to my proper fraction. I get 6 plus 2 is 8. That's 8, 6. And here's my improper fraction. Again, this value, though, stays the same as this. That stays the same as that. These all agree as far as amounts. I haven't changed. I haven't added anything to it or subtracted anything yet. I'm just arranging my fractions and my whole numbers. Now I'm going to subtract the same number, minus 5 and 5 6. Now at this point, my fractions, this one is larger than this one now. 8 6 is larger than 5 6. If I have 8 6 and I subtract 5 6 from it, that gives me 3 6. And if I take 6 and I subtract 5 from it, that gives me 1. So by subtracting these fractions, this is my difference. This is my results here. And when we subtract, we call this the difference. Okay? So this is my results. I don't have an improper fraction anymore over here. I have a proper fraction and a whole number. So this is one way of doing it. Okay, the second way, which I think might be a little bit more complicated, but maybe you guys can come up with your own way. Maybe there's a third way. There's all kinds of ways as long as we use what we know in solving these problems. The second way is, let's take 7 and 2 6 minus 5 and 5 6. And again, we're still going to look at the fractions first, and then we'll get to the whole numbers. And I'm focused on this one primarily. Now, if I were to take 7 whole fractions, okay, that's what this means. So let me just put off on a note here. I could take this 7, and that would be 6 6 plus 6 6, 1 2 plus 6 6. I need 7 of them. 3 plus 6 6. I'm running out of room, plus 6 6 plus 6 6. 1 2 3 4 5 6. Woo! Plus 6 6. Now that gets a little complicated, but that's what this 7 is worth. That's the value of this 7 in whole fractions. Again, this here and this over here all equal the same. Now, our denominator stays the same. Remember, I showed you once where we could take, and since the denominator stays the same, we could just add everything at the top here. 1, 2, 3, 4, 5, 6, 7. So there's my 6 6 all added at the top there. Well, I could take this and use skip counting to figure what this is. 1, 2, 3, 4, 5, 6, 7. What's 7 times 6? 42. So 42 6. So this and this and this are all the same thing. Now if we look here, kind of a shortcut way of remembering this is we could take the denominator here and we can multiply it by the 7. In other words, we don't have to go through this whole lengthy process. We can just take the 6 and we can multiply it times the 7. And we get the same number, 42. So let's take the 6 and multiply it by the 7, and we get 42 6. Okay, but we have 2 6 here. So again, this and this are equal. They're equivalent. They're the same amount. Now, in this second way of doing it, I'm going to do the same thing here, but I'm not going to do this anymore. I'm just going to use the shortcut method, and I'm going to say, well, 5 6 6. This was 7 6 6. What if I just do it 5 times? Let me take 2 out. 5 10 1 2 3 4 5. What's 5 times 6? 5 times 6 is 30. 36. So this one's going to be 36. That's this whole number. Plus 5 6. So now what I did is I converted my whole numbers into whole fractions. There's 7 6 6 here, and there's 5 6 6 here. Okay, and this is kind of how I did it for the 7 and the 5. I kind of shortcut it, just crossed 2 of them out, and that gave me 5. 1 2 3 4 5. So now I can use my skip counting instead of my multiplication knowledge to to quickly come up with what these are going to be as far as our numerators instead of adding them. Now, I'm going to add these together. So 42 plus 2 is 44.6 minus, and I have 30 plus 5. That's going to be 35.6. What's that going to equal? Look at this. I have a larger fraction over here now, 44.6 versus 35.6. So I'm just going to take 44 minus 35. And 9, what's that? 9.6? Now watch. Now 9.6, if we break this down, or what they call decomposing, if we decompose this, we have a whole number again, because this is a very small improper fraction, and we have a proper fraction. So this one becomes 1, boop, and 3/6. Oh my goodness, look at that. It's exactly the same amount. So there's all kinds of ways of coming up with answers for these. We're just staying on this side and doing it in method number 1, or changing both sides to improper fractions and subtracting as number 2. So you can use either one of these methods as long as your difference is the same. It doesn't matter how you arrange your improper fractions, your whole numbers. Coming up with the answer is, after all this work, is what we're trying to do. Now, there's not a lot of them here because there's a lot of work that has to be done to do subtraction. It's not as easy as addition, is it? So take your time. We'll probably do one in class or one on together on our Zoom meeting. And we'll practice this a little bit as we go along. It's a little bit hard to keep all this in your head, but I think you guys are ready for it.